Differentiation of logarithmic functions. First of all, the derivative of ln x. So ln x is a natural logarithmic function. The derivative of ln x is equals to 1 divided by x. And if you have a function inside the ln, that means this is a composition function. So the derivative of ln of f of x. So we have a function f of x inside the natural log function ln. So that is equals to, you have 1 divided by whatever that function is, and then you multiply the derivative of that function. This is by the chain rule. And then finally, we have the derivative of log. So this is log is common logarithm. So log base b of x, that is equals to 1 divided by x times ln b. When you do derivatives in your business class, economics class, or even a calculus class for engineer, most of the time you will be handling the derivative of ln. So the derivative of the common logarithm log of b, that one you don't see that very often. So in this video, I will mainly focus on the ln. All right, so the derivative of log base b of x is 1 divided by x times ln b. Okay, so you don't use that very often. So if you can do the ln, then you can do the log. All right, so first problem, we have f of x equals to ln, and then parentheses 6x to the third minus 4x squared plus ax minus e, and then we need to take the derivative. So we have f prime of x. So first of all, the derivative of ln, you bring the entire thing to the denominator. So let's draw a fraction bar. So we have 6x to the third minus 4x squared, and then plus ax minus e, and then the top is a 1, right? And then since we have a polynomial, the third degree polynomial inside ln, then we have to take the derivative of the entire function inside ln using chain rule. So that will be d dx, and then 6x to the third minus 4x squared plus ax minus e. And then the next step is you handle the derivative, and then you put the result in the numerator. So we have f prime of x, so that is equals to, what's the derivatives? So that is 18, right? So we have a 18x squared minus ax, you bring the 2 down, and then the derivative of ax is equals to 8, the derivative of e is equals to 0, because e is a constant term, and e is approximately equals to 2.7. And then the denominator, no change. So 6x to the third minus 4x squared plus ax minus e. And then this is your final answer. So this problem, I don't mind if you just do it in one step. So I give you this, just give me one step, and I will, if your answer is right, you will just get full credits. So with a little bit of practice, you don't really need to show this line. But since this is a lecture, I expect that this is your first time learning this, then I prefer to show that line, even though that is for extra work. All right, so let's move on to the next one. So the next one, we have ln, right? So the next one, we have f of x equals to ln, and then we have a 6x divided by 3x squared minus 9x plus 10. So this one you can say, all right, so when you take the derivative, I have 1 over ln, the entire piece inside the parenthesis, and then I will do a quotient rule. But we can make things easier than that. So first, I have to recall, do you still remember the properties of ln? So if you have ln a divided by b, that equals to ln a minus ln b. So this function is f of x equals to ln 6x, and then minus ln, the denominator, 3x squared minus 9x plus 10. So if you do this first, this will save you a lot of work from doing chain rule. So every time you take derivatives of ln, tell yourself, can I use the properties of ln to rewrite the function? If you can do so, that will save you a lot of work. And then now we take the derivative. So since in this video, I will be keep moving down. So now is a good time to just take a screenshot so you have all 6 functions. Then you don't have to keep rewinding the video. So f prime of x. So we have 1 divided by 6x, right? So this is 1 divided by 6x. And then the top is supposed to be a 1. And then am I missing anything? So you have to take the derivative of 6x. So therefore, the derivative of 6x is equals to 6. And then instead of writing 1, we will put a 6 on top. And then the next term, the derivative of 3x of Ln of this thing, so you put the entire thing in the denominator, and then you take the derivative of the second degree of the quadratic equation, so that is 6x, right? Minus 9, the derivative of 10 is equals to 0. And then this one you can simplify the 6, and then that gives you the final answer. So this one you have f prime, that is equals to 1 over x minus 6x minus 9 divided by 3x squared minus 9x plus 10. So with a little bit of practice, you don't need to write an extra line to tell me that you are taking the derivative of the inside. This is easy to tell. At this point, you are supposed to be very familiar with the chain rule. If you are not able to do chain rule at all, or you miss chain rule all the time, you should check out my other videos regarding chain rule. So at this point, you have to be able to do the chain rule. You have to get it right 100%. Okay? If you cannot, you have to check out the old videos, the one regarding chain rule. All right, that is your final answer, and I don't think there is a point to do a common denominator. All right, let's move on. So moving on to the next one. So we have a Ln big square bracket. Okay, let's use yellow. So we have f of x equals to Ln, and then we have a square bracket 3x plus 2, and then e to the 5x minus 4x close parenthesis close square bracket. So this one I have to recall that Ln a times b equals to Ln of a plus Ln b. So this one I can break this into two pieces. Otherwise, you will have to do 1 over the entire piece in the square bracket, and then you have to do a product rule. So if you break it down, then that will save a product rule for you. So the function is f of x equals to Ln 3x plus 2, and then plus Ln e to the 5x minus 4x. So let me ask you a question. Can you break down the plus and the minus? So can you break down this plus and can you break down this minus? The answer is no, no, no. For plus and minus, there is no way to rewrite them. It is what it is. But this is already simple enough because I just save a product rule for you. So, and then you go ahead and proceed to the derivative. So you have 1 divided by that. So 1 divided by that. And if you don't want like me skipping steps, I will just write this down for you. So d dx 3x plus 2, this is by chain rule. And then you bring this entire piece in the denominator. Have a 1 on top. And then you do a chain rule. E to the 5x, 5, right? That looks like 5 minus 4x. So this is a chain rule, and then this is a chain rule. But I prefer to just do this in one step. Like I said, you are supposed to be very familiar with the chain rule at this point. If you cannot do chain rules at all, or you miss the chain rule all the time, you have to go back to my previous video regarding chain rule. So f prime, that is equals to the result. So this is a 3, right? And then we have a 3x plus 2, and then plus the e to the 5x minus 4x, the derivative that is a minus 4, and then e to the anything is e to the anything. So when you take the derivative of 5x, you have a 5 in front, and then this is your final answer. All right. So let's move on to the next ones. Do you see the next one? We have Ln parentheses raised to the 10th power. So the next one we have Ln parentheses. So let me pick a color. So let me pick orange. So let me copy the problem first. So f of x, so that is equals to Ln, and then e to the negative 3x plus 8 x squared, and then raise that to the 10th power. So I'm going to move down so you won't see the last two problems anymore. So now is a good time to write it down, or you take a screenshot. All right, so let's move down. So this one we have to recall the properties of Ln, so which is Ln, you have a base raised to the nth power, so that is equals to n times Ln of a. You bring the nth power down. This is one of the biggest purposes to study Ln, is to carry the power down. And then the function is f of x equals to bring the 10 down times Ln, and then e to the negative 3x plus ax squared. So now, when you take the derivative, all you have to do is you take care of the Ln. So f prime of x, that is equals to 10, and then the ln is always 1 over, right, e to the negative 3x, and then plus ax squared by chain rule. We have to take the derivative of the e and the ax squared. All right, so this is by chain rule. And then let's finish this up. So f prime of x. So we have a fraction bar, e to the negative 3x plus ax squared. And then the e, so e to the negative 3x. So there is a negative in front, right, due to the chain rule. And then the ax squared becomes 16x. And then the 10, you can either keep it outside or you multiply the 10 in. So I will just take this as the final answer. If you are doing homework online, I'm not sure if they let you keep the 10 over there. If they don't allow that, then just distribute the 10. All right, so that is another problem. So here is the fifth problem. So the fifth problem, I would like to put it right over here. So the fifth problem, so that is f of x equals to square bracket. This is raised to the 10th power. And then we have ln negative 2x to the third plus x squared. So that looks like the previous problem, right? That looks like the previous problem. The reason I put this up is because why don't you write this down? Very important. So if you have ln, all right, so if you have ln 3 squared, that is equals to 2 times ln 3. This is approximately equals to 2.197. Okay, but if you have ln 3 and then you square the whole thing, that is equals to ln 3 times ln 3, and this is approximately equals to 1.207. So what I am trying to say is if you have ln x squared, that is not the same as, so this square ln x squared, that is not the same as ln x squared. What is the difference? The one on the left is you square the x first and then you ln the whole thing. The one on the right is you ln the whole thing first and then square. Once again, the left hand side, square first and then ln. The piece on the right, ln first and then you square the result. So they are not the same at all. Okay, so back to this problem. So let me ask you a question. Can I just bring the 10 down? Can I just bring the 10 down to the front? Can I? Your answer is no, right? There is no way to bring the 10 down. Likewise, there is no way to bring these two down. Okay, so that's why I make this problem. Then what can we do? Let me just copy and then paste. So start clean. Then there is nothing to carry down, then you have to start the derivative. So when you start the derivative, do we agree that this is a chain rule? We have this function inside a 10th power. So that means I don't care what is inside. I have something over here. I don't care what it is. So first, I need to bring the 10 down, and then this is a 10 minus 1 equals to 9. All right, I don't care what is inside, and then you take the derivative of everything inside using simple power rule. So this piece is a chain, but the 10 and the 9, that is a simple power rule. So let's fill up the blank. We have ln negative 2x3 plus x squared, and then ln negative 2x to the third plus x squared. Alrighty. So what's the derivative? The derivative is you have this, right? You 1 over the whole thing, and then you take the derivative of the third power and the second power. That becomes a negative 6x squared, and then plus 2x, and then the other piece is right over here. So you can just copy this, copy, and then bring it down. That's it. That is your final answer. So this is your final answer. Okay, back to pen for writing. So that is your final answer. Let's erase the dots. Yep, that's your final answer. So let's take a look at this weird function. So the very last function I gave you is this, right? I gave you f of x equals to ln of 2x. And then f prime of x, so first we take care of the ln outside, which is right over here. That becomes 1 divided by ln of 2x. So since you have this inside another ln, then we have to use chain rule to take care of the derivative of ln 2x. The derivative of ln 2x is your 1 divided by the whole thing, and then the derivative of 2x is equals to 2. So you erase that, and then you put a 2 over here. This is 1 over ln 2x. So that's your final answer. Of course, you can simplify the 2's, right? You can simplify the 2. So that becomes a 1 on top. So 1 divided by ln of 2x, and then multiply 1 over x. Okay, so that is the end of this video. If my instruction is helpful and clear, give me a like, share the video on any social media like Facebook for me. If you are new to the channel, click the subscribe button before you leave. I will see you all in the next one. Signing out.